Hi, welcome to College Algebra. We're going to start this section that corresponds to your lecture notes for week 1, section R.1 by talking about what does multiplication mean. Here on the left hand side you see 2 and an x and a 3. That straight x means multiplication. Anywhere in your textbook that you see that, it will mean multiplication. If it means the letter x or the variable x, it will be written like a scripted x. The next one down is a star, and that also means multiplication. The dot also means multiplication. And the fourth one you see in that column with parentheses around that number is a standard way of expressing multiplication in algebra. When there's nothing between those two inner parentheses and they're side by side, that indicates multiplication. Those symbols could be square brackets like in the middle column, squiggly brackets as in the middle column, or it could be a number out in front of any kind of a grouping symbol with nothing between the 2 and the parentheses, such as there cannot be a plus sign or a minus sign between those. As long as the 2 is next to that parentheses, it indicates multiplication. On the far right-hand column, we're beginning to see things that look more like algebra, where we have things expressed as letters. And we don't know what A and B are primarily. So if you see 2AB, it really means 2 times A times B. If we knew that A was equal to 2 and B was equal to 3, then we could say 2 times A would be 2 times 2 or 4, and then 4 times 3 would give us a 12 for the expression 2AB. The next expression, ABC, also means A times B times C. So if A was equal to 2, and B was equal to 3, and C was equal to 4, we would have 2 times 3 for A times B, which would give us 6, and we would take that result and multiply it by the value of C, which we said was a 4, and end up getting a 64. The last expression also is a number next to a grouping symbol with nothing in between it, so that again means multiplication. So here we have 2 times 4, which is going to give us to 8. We're going to talk about what those horizontal or those vertical lines mean in a little bit. They're going to actually mean something called absolute value that we'll talk about in a few minutes. The expressions that we have for division, fortunately, are not as numerous. Whenever you see a 2 and then a slash, whenever you see a 10 and then a slash and a 2, that's going to mean division. A lot of times we write it like that because division is a little bit harder to write using Word, so the slash will indicate division. The middle expression is how we typically write fractions, 10 over top of a 2, so that again means 10 divided by 2 is equal to 5. And in the third expression we see the true division symbol, and again it means 10 divided by 2 is equal to 5. We're going to talk about properties of real numbers. Properties of real numbers are going to be important for us as we manipulate some of our numbers and some of our letters. For addition, this property is stated as A plus B is equal to B plus A. The commutative property is similar to the word commute. When you commute from your house to work, you go from your home to work and then work to back home. The direction changes. That's what commute or commutative property means for algebra as well. So here we use it as 3 plus 5 is equal to 5 plus 3, or 8 plus 6 is equal to 6 plus 8. The main importance of this property is going to be as you go to check your answers with me or with your textbook. If you have an answer of 3 plus x, and the textbook has x plus 3, those are going to be the same answers because of the commutative property of addition, that the order that you have those terms listed in does not matter as long as you have the proper terms. They could be in actually any order. The next property we're going to talk about is the commutative property for multiplication. It's very similar. A times B is equal to B times A, 3 times 6 is equal to 6 times 3, etc. Notice that it is not a property for subtraction. 7 minus 3 is not equal to 3 minus 7 because 4 is not equal to a negative 3. For the commutative property, the order changes. The next property that we're going to talk about is called the associative property. For addition, it's stated as A plus the grouping of B plus C is equal to the grouping of A plus B, and then that added to C. Our example that you see here has 8 plus 4 gives us a 12, plus the 3 gives us 15. On the right-hand side, we add the 3 and 8 first and get 11. 11 plus 4 gives us the same answer. You'll note that the order does not change. What does change is the association. So the grouping is going to change for the associated property, but the order is going to change for the community property. For multiplication, the property looks very similar. We multiply different two numbers together, so our example has 3 times 8, which is 24, and then 24 times 2, which is 48. Our right side gives us 2 times 3 is 6, and 6 times 8 is equal to 48. Again, this property is going to be important because there are going to be some times that we can't multiply things when they're letters. So by changing the grouping of them, we might be able to add or multiply it by something else that's there if we have a letter. The identity properties are 2. The 0 is called the additive identity element. For addition, it just means that there is a number that you can add to anything and it doesn't change the way that number looks. So a plus 0 is equal to simply a. The number 10 plus 0 is simply equal to the number 10. For multiplication, it's called the multiplicative identity element. We can take 1 and multiply it by any number and we don't change the value of that number. For example, 10 times 1 is equal to 10. You can multiply the value in your checkbook by 1 and it doesn't change the value in your checkbook. The inverse property is a number and its additive inverse, which is its opposite, add to 0. They're called additive inverses. So 10 and negative 10 are additive inverses. We're going to use this property quite extensively when we get later in the book in chapter 2. A number and its multiplicative inverse multiplied to the number 1. So 5 times 1/5 would be equal to the number 5 over 1 times 1 over 5. You would multiply the two tops together and get 5, and multiply the two bottoms together and get the number 5. Any number divided by itself is going to be equal to a 1 with the exception of 0. 0 is a special number that we'll talk about later. So remember that 10 divided by 10 is equal to 1. Negative 11 divided by negative 11 is equal to 1. Any number divided by itself is equal to 1. The distributive property is one that you may not have had. It's going to be a very important property that we're going to use extensively throughout this class. So if you haven't used it, you might want to do a little bit of extra work and make sure that you understand it. It has the letter A on the outside of a grouping B plus C. If we know what B plus C, each of those values are, we could add it together and then multiply it by B. Or we have the possibility of taking A times B plus A times C. We can do it either way. So in our example, we can add the 10 and 5 together and get 15, and then we'd multiply 12 and 15 together and get 180. I don't know about you, but I'd probably need a calculator to do that. On the right-hand side, though, if I take 12 times 10, and then I add that to 12 times the 5, I've multiplied the 12 on the outside by each of the two values inside. In my head, I can multiply 12 times 10 and get 120, 12 times 5 and get 60, and add the two together and get 180. Again, each of these is a correct way to do it. Sometimes we're going to have to use the distributive property when we don't know the value of something in the parentheses. Our next example has the grouping, and it shows where 5 is multiplied by the quantity of 6 plus 10 plus 3. So if we added those together, we would get 5 times 19. On the right-hand side, though, we can take the 5 times the 6, and we can take the 5 times the 10, and we can take the 5 times the 3. If we do this, we get 5 times 6 is 30, 5 times 10 is 50, and 5 times 3 is 15. You'll note that sometimes you can have parentheses on one side, but not on the other. It primarily depends on what symbol that you're using for multiplication. If we wrote multiplication using the parentheses, as in the example that you see here on the bottom of this page, then both sides have parentheses. What I'd like you to do now is identify what these properties are. There's 7 of them here, so if you'll take the time to do that, and then after you've done that, on the following page, you'll see that the answers to these problems. I'm going to stop the video here and label this part 1, and then we'll go on and we'll continue on the next section.